4.2.9, determine whether the graph of the rational function has a horizontal asymptote. So the horizontal asymptote has to do with the degree of the numerator, which would be 1, that x to the first, and the degree of the denominator, which is 2. So if you kind of think about this, a horizontal asymptote is when you go out to infinity, either on the left side or the right side for, again, horizontal. If you take a look at these two terms, because those largest degree terms are what's going to determine that, you kind of could simplify this, and it would be like 14 over 4x. And again, because we're going to infinity, it's really the x that dominates anything here. And it would be like it's going to be something over infinity. And that goes to 0. So my horizontal asymptote here on this one would end up being on the x-axis, because this is like y equals 0 is the x-axis. So the graph of this has a horizontal asymptote, and it would end up being at y equals 0, which again is on the x-axis. Now, if the degree in the numerator is larger, that means you're going to have like an x squared over an x, and when you reduce that, that's going to be x with another number there. So there's going to be a slant asymptote, and you have to divide that out, long division or synthetic, and find out what the solution is. So if I came up with 2x minus 3, this would be the equation of the line, 2x minus 3, so minus 3, slope of 2, and dotted line usually for denoting an asymptote. If the degree on the numerator and denominator are the same, so if it's say 4x squared is the highest on bottom, and then or a top and the bottom is like 5x squared, because these infinities would reduce or cancel each other out, then my horizontal asymptote would be at 4/5. So those are the three possibilities. It's all based off from the degree in the numerator, degree in the denominator, and then those three possibilities. Bigger on top, in the numerator, divide it out, whether it's long division or synthetic or whatever, and the equation you end up, if it's bigger on the bottom because of this infinity in the denominator left, anything over infinity is going to be 0, so the x-axis. If they're the same, then it's going to be the coefficients of those leading terms in the numerator over the denominator. So that's how you're going to work with the one that was the slanted line, sometimes called the slant asymptote, sometimes called oblique. So 4.2.29.